All right, AP Calculus. We have a special guest today. Say hi, Atzuri.
Hi.
Atzuri has been taking AP Calculus, right? I think this is Calculus. Is that right?
Yeah.
Yeah. So she's been taking AP Calculus this whole time in the background, and she's been about Ben's level. She hasn't really missed very many questions.
She's like the first time
I'm like unveiling this amazing calculus student that I have. I don't know how you guys all missed that she was in AP Calc, but she has been. So let's talk about number 2. This was on the actual AP test. Again, how did we do on this? Arrow got a 3, Ben got a 9, Rochelle got a 7. So this is mainly for Arrow, although again a 3. You're passing at a 3. You passed 3.0. So you can improve, though. There's always room for improvement. Sorry, Ben, not really room for improvement. This is for Rochelle and Ben, and maybe Atzuri, but Atzuri's at Ben's level. So no, Atzuri's at Ben's level.
No. I'm sorry.
All right, so for part A, again, this is in a calculator question. Do you both have calculators?
No.
No? Okay.
I can't find mine.
That's not good, because that's like $100.
I know. I'm gonna find it. It's just spring cleaning, man.
Spring cleaning. Okay, so make sure that you have your calculators open. I'm going to open up mine. Wabbit EMU. Too many B's there in my Wabbit. Silly Wabbit. Tricks are for kids. All right, so.
Wait, she doesn't know how to use a calculator.
That is okay. She'll pick it up real quick. I know that it's a little bit of a review. So 82 plus, we're plugging all of this into the calculator. So I went to the Y equals button. 82 plus 4 times sine of, it's going to be x divided by 2, and your parenthesis, and there is our function. We're good, Rochelle? Are you doing this with me, or are you not doing this with me?
I am.
Okay, so I have my function, and I need to know to the nearest whole number how many cars pass through the intersection. So if this is a rate, it says the traffic flow. Flow is modeled by, oh yeah, it says it's a rate right here. If this is a rate, it's a positive rate. This function is a positive rate, which means in order to get a number, I need to take the integral. So for part A, I'm looking for the integral. So over the 30-minute period, so between 0 and 30, and that makes sense because that's the domain, from 0 to 30 of this capital F of t function dt. All right, we already know how to do that, so let's get out of here. We're going to do math. Oop, that's not math. Math 9. So it's going to be an integral of var's right, enter 1, y1 with respect to x from 0 to 30. And we should get the answer. We have the key in front of us, so that's the other key. That's the wrong key. There's the key I'm looking for. If I scroll up to problem number 2, it should be 2,474. Let's see if we are actually getting that. 2,474. Nice. To the nearest car.
Mouse.
What? Really?
Yeah. Math 9, y1.
Check your mode. Are you in ratings or degrees?
Radians.
Okay, ratings isn't the problem. Did you type in your y equals function? Check it with mine. This is
Y equals 482.
82.
Plus 4.
Yep.
Sine.
Yep.
Of 1/2. Oh, t.
X divided by 2. Yep. So if I quit out of this, and so this guy is approximated by 2,474. 2,474.078. But it says to the nearest whole number, so this is to the nearest whole number, cars. All right, on to part B. I'm going fast because I know Rochelle and Atzuri know everything that they're doing in here. Is the traffic flow increasing or decreasing? So it's talking about the flow. This is the flow. So if I'm talking about the flow increasing or decreasing, I'm talking here about f prime. So if it's ever talking about increasing, you're taking the derivative of whatever you're talking about. I'm taking the derivative of traffic flow. I'm taking the derivative of capital FT. So I can actually just graph this and check the slope. So I'm really checking about f prime. Is f prime of t positive or negative? That's the question. So I'm really talking about slope of capital F of t. And I have f of t. Let's graph it from 0 to 30. So if I go to window, 0, enter, 30, enter, I do zoom 0, and it will automatically graph this for us. Go, go, go. And I'm looking at the slope. So if I come back here, I need to know at t equals 7. So I can come back here and I say, just hit enter 7. Oh, I have to trace, that's why. So trace 7, enter. And that's where 7 exists. Is that a positive or a negative slope at Ziri? At this spot, is that a positive or a negative slope? It is a negative slope, yeah. She's as good as Ben. So this is a negative slope. So if it's a negative slope, is it increasing or decreasing at Ziri? If it's a negative slope, is it increasing or decreasing? Yeah, exactly, yeah, decreasing. So the answer here is traffic flow is decreasing. And as Ziri said, is because that f prime of t is negative.
Wait, so how did I get the point if I didn't say which slope?
Did you say it's decreasing?
So I said the flow is decreasing at t equals 7 because the slope is decreasing.
Oh, slope of what though?
So then
Slope of f of t or slope of f prime of t?
Oh. So then how did I get the point?
You got 1 point because you said it's decreasing, but you didn't say, you said the word slope, but you didn't say slope of f of t. If you said slope of f of t, you would have got another point.
Oh, so that's right.
And technically it should be f of 7 because we're plugging in 7 here. All right, that was part B. Part C. What is the average? Oh, average. We have been making so many mistakes with average lately. Let's see if we can get this correct. Average value. The average formula is 1 over b minus a integral from a to b of blah, of that thing that I'm talking about. This has to be engraved in our minds. So I'm looking for the average flow over 10 to 15, which means my integral that I'm actually looking for is 1 over 15 minus 10, integral from 10 to 15. And I'm talking about average value of traffic flow. So of the anything, this thing is traffic flow. Traffic flow is capital F of t. So this anything is capital F of t, dt. Over 10 to 15. And I do need to do units here. So again, enter this on your calculator. Let's get out of here. I'm going to do 1/5 because 15 minus 10 is 5. So I'm going to do 1/5 of, or times, math 9, the integral of, var is right, enter 1, y1 with respect to x from 10 to 15. Boom, hit enter, and it should give me my answer as 81.899. So this is approximately 81.899. Did I get that correct, Mr. Sindel? 81.899. Ooh, I forgot my units, of course. So if I'm talking about the average of something, the units will be whatever that something was. So, Atziri, can you read this off for us? Atziri has our answer. Atziri got another point by saying it is cars. Oh, what's going on here? Cars per minute. You do need units there. The original units, because I'm talking about the original function since it's average of the rate, well, the rate was measured in cars per minute. Thank you, Atziri. All right, we're on here to part D. Okay, oh, average rate. We're talking about average yet again. Average rate of change. So now I'm taking average rate of change. Change is now taking the derivative. So what is the average rate of change over all this thing? Well, so there's two ways to think about this. Most people don't do it Mr. Sindel's way, so I don't know if I should continue showing this. But I'm doing the same thing, 1 over b minus a of the integral from a to b of that something, but I'm going to take the derivative of this something, or d dx of that something. What that literally translates to is the secant line.
That just seems like, how do I say it, like confusing. In my opinion.
Is it confusing knowing that you need to take the derivative? Or
The derivative of the integrals. I don't know. It's just,
well, the derivative of the integral is nothing. Going forwards of backwards is nothing, right?
yeah.
So all you are going to have when I take the derivative is going to be capital f of b minus capital F of a when I actually do my definite integral, all over b minus a. And this is the definition of a secant line.
Oh, okay. That's fine.
So yeah, if you just did a secant line, that's what you're doing here. So our secant line, what is f of a, f of b? We actually have to come back to our calculator. We have to trace out f of b. Oh, maybe I should write out what b is. We're doing 10 to 15 again, so if I write this out, this is going to be f of 15 minus f of 10 all over 15 minus 10. So if I type in 15, enter, again I'm using my trace function. At 15 I'm at 85.752. I'm going to run out of room here. I'm going to come down to the next line. 85.752. 752 minus, now I'm going to plug in 10 because I'm doing f of 10. So 10 equals, and it's 78.164. 78.164. All of this divided by n at 0. Can you simplify the denominator for me? Say it louder. Yes, all right. So now I'm going to do this on my calculator. So second, quit, and I'm going to do 85.752, and I know that the question in everyone's mind is, wait, Mr. Sindel, you rounded. I rounded to 3 decimals. It's going to be off maybe a little bit. It'll be off more if I was multiplying. If I'm dividing, it won't be that bad. So 85.752 minus 78.164. If I do that and then divide by at series 5, I get 1.5176. Did I get it right? 1.5176. Hey, well, I'd have to round. And 1.517, 1.517. That is what I am looking for. And I guess I could do 1.518 also if I round up. So 1.518, and it does say indicate units of measure. Okay, well now I'm taking the derivative. So if I'm taking the derivative of rate of change, I need to add another per minute. I've been giving that Zuri way too many questions. Rochelle, can you do this one? So if the original was cars per minute and I need to take the derivative of that, I'm now cars
Per minute squared.
there it is. Cars per minute squared. And again, you can check the answer key. It should be cars per minute squared. All right, so that was the AP test that we took last Sunday.
So if we ever have to find the average rate, we always have to have whatever they give us for the units thing. The what's it called again?
So for the rate, this was the rate, right? Rate was given in cars per minute here. But if you ever take the derivative, because it's saying rate of change,
You always have to square it at the bottom.
then yeah, square the bottom, essentially. Well, or add another minutes. Because what if it was just cars? Now I was taking the derivative of that. If I took the derivative of cars, now it turns into cars per minute. Take the derivative again, oh, it's minutes squared. Take the derivative again, minutes cubed. Take the derivative again, minutes to the fourth. You just keep adding on minutes whenever you take a derivative. All right, let's get rid of that. Let's go on to that packet. So at Zero, you have this packet in front of you. You didn't have the AP test in front of you. This packet right here, everyone has this? All right, we're doing the same type of problem. Now, oil is leaking from a pipeline of the surface of a lake. So think about an oil circle that's getting bigger and bigger and bigger on a lake. This happens, sadly, like whenever you do an oil spill, oil does start coming out in the form of a circle. It gets distorted and stuff by wind, but for the sake, let's assume no wind, perfectly flat lake, circle is increasing, yeah? So whose oil slick, whose volume increases at a constant rate of 2,000 cubic meters per minute. So Rochelle, what should I label this? Is this V, V prime? What is 2,000?
2,000 is hold on. So leaking from pipeline surface of the lake becomes more so it increases. Oh, so it's gonna be V prime.
V prime, yeah, it's a rate. It says rate right here. So it's a rate. V prime is equal to 2,000. All right. And that's in, our units are going to be cubic centimeters, so centimeters to the power of 3 per minute. The oil slick takes on the form of a right circular cylinder. So the shape that this oil is taking is going to look like this. It's a very thin cylinder, both with its radius and height changing. So it's getting, you can think of the cylinder getting bigger this way, and it's getting deeper as well. So it's increasing in both dimensions. All right, and it tells us, oh, if you don't know the volume for a right cylinder, there it is. Again, I told you guys, you needed to know the area of a circle. That's it, and Pythagorean's theorem. Everything else they'll give you. If you don't even remember a cylinder, they will give it to you. They're really nice about that. All right, let's do part A. Everyone write down part A. So, at the instant when the radius of the oil slick is 100 centimeters. All right, Etsy, what does that mean? Radius, 100 centimeters. What variable should we use for radius? What letter? So, and that's going to be equal to 100. Perfect. So r is equal to 100. Just keep writing down everything that the problem gives us. Thank you, Atziri. Rochelle, what is this going to be? Height is 0.5.
H equals 0.5.
H equals 0.5. Perfect. The radius is increasing. Oh, okay. So if it's increasing, Rochelle, is that r or r prime?
R prime.
It's r prime. So r prime, whenever it's increasing, it's r prime at 2.5. So r prime is equal to 2.5. At that instant, what is the rate of change of the height?
So it's going to be, we're trying to find H prime.
H prime. H prime is equal to what? We'll leave that as a blank. That is our question. And it already tells us the units, so we don't even need the units. We can even leave the units off and still get the point.
Well, we could find H prime by changing the right cylinder, like whatever the know what they gave us.
Mm-hmm.
We could just change that to V prime.
Okay, so yeah, you're saying take the derivative of this v and change it to v prime. So when I take the derivative, Rochelle, can you do that for me?
V prime equals pi, 2 pi r's. Sorry, hold on. 2 pi r prime H prime.
Ooh, okay, so the problem here is that you're incorrect because there are two variables being multiplied together. Whenever you have two variables multiplied together, what rule am I using, Rochelle?
Oh, 1d2 plus 2d1.
Yeah, this is going to be 1d2 plus 2d1. So let's leave this, let's leave the pi out front. Let's leave the pi out front. But I am going to be using 1d2 plus 2d1. So 1d2 plus 2d1. That's our product rule.
R squared times by 1.
So r squared times, well, what's the derivative of h?
Prime.
Yeah, so r squared h prime. And do set up your parentheses here. That pi is being factored out. So r squared h prime.
And plus h times by 2 r prime.
H 2r r prime. Very well done. Yeah, good job. And notice that none of these variables cancel out because you're taking the derivative with respect to t. If there was a t in here, the derivative of t would have been 1. But there was no t, so you always have to leave them h prime, r prime. Good job so far. All right, so let's start plugging things in. Atziri, what do you see? Out of all these variables that we have written down, what should we plug in? Do we have v prime? Somewhere up here? What do we have? All right, let's plug it in. 2000 is v prime is equal to, we still have this pi, so let's leave the pi. Anyone, either Atziri or Rochelle, do we have an r?
Yeah.
What is r?
100.
Okay, let's plug that in. So let's say plug it in 100. We still have to square that. Do we have an h prime?
No, that's what we're trying to find.
Oh, we're trying to find h prime, so let's leave h prime. I'll even make that a different color to make it pop out. H prime. I'm going to continue writing the rest of this. Plus, do we have an h somewhere, Atziri? Do we have an h? I'm looking for an h. Do we see an h somewhere up here? Okay, let's plug it in. 0.5. So 0.5. And then we're going to multiply that by 2. Do we have an r somewhere? Either of you two?
Yes.
Where is that?
Wait, R prime?
I'm looking for, so I haven't done this r yet.
R, so it's 100, and R prime is 2.5.
And r prime is 2.5. Okay, we just plugged everything into our formula here after taking the derivative. Now we just got to solve for h prime. That's like solving for x. So let's plug all this stuff in. And notice that this is problem number 3, which means there are no calculators. You're not allowed to use your calculator. Problem 1 and 2, calculator. 3 through 6, no calculator. So from here, let's multiply. Ooh, here's an easy one. Let's do 100 times 2.5. Move the decimal place twice. So Rochelle, do that.
So it's going to be 250.
250. And then 250, what's half of, half of 2.
Wait, what?
So this thing right here you just told me was 250, right?
Yeah.
Well, what's half of 2?
That's going to be 1.
1. Okay, so that means this entire thing right here is 250. Ooh, okay, so if I double the amount of zeros, it's going to be for Atziri. If I double the amount of zeros, I had 2 zeros, and I double that, I'm going to have how many zeros? Double 2? 1, 2, 3, 4. Okay, so it's going to be 10,000 h prime. I'll leave h prime right here. Thank you, Atziri. Plus 250. Plus 250 is now equal. Oh, that all has to be multiplied by pi. So let's. We can just leave the pi on the outside if we want.
Can we just divide pi to the other side?
Should we just? Yeah, let's go ahead and do that. So let's say that that's equal to 2,000 and divide that by pi. So that way we moved it over. All right, next.
Now we can just subtract 250 to both sides.
Subtract 250, so I'm now left with, I'm going to do this in black now, 2,000 divided by pi. Rochelle just subtracted 250s, minus 250. That's equal to 10,000 h prime. All right, at Zeri, how do I get h prime by itself? How do I get h prime by itself? What do I have to do with this 10,000? Yep, let's do it. So divide both sides by 10,000, and I get my final answer as 2,000 divided by pi minus 250. All of that divided by, at Zeri's 10,000, is equal to h prime. Done. There it is. We don't need to approximate that because there's pi in there. That's gross. I'm not going to do anything with that. Of course, I could simplify this fraction a little bit. I could say that this is 250. Let me write this in a different color. This is 250 pi over pi. So this is really, if I want to simplify this one more step, I could say that this is 2,000 minus 250 pi. All of this divided by 10,000 pi. There, and that's a little bit simplified. Again, if you are ever confused on why this is the case, it's a keep it, change it, flip it. Hopefully I did that right. Keep it, change it, flip it. Yeah, and then this 10,000 comes down here. Perfect. And there is our final answer, and we box it. Bada boom, bada bing. And I think we just used like all of our space. Darn it. Okay, that was only part A. We have B and C. Oh, God. Did you guys at least conserve space?
Yep.
Okay, good. I was writing too big. I was getting too crazy. All right, B. A recovery device arrives at the scene and begins removing oil. Okay, so oil, this was a positive rate. Now it's going to remove oil. The rate at which the oil is removed is this function, where T is in minutes. Oil continues to leak at a rate of 2,000 cubic centimeters per minute. So V prime is still 2,000. Find the time at which the oil slick reaches its maximum volume. All right, so Rochelle, definition of F max. Yep.
Would be F prime goes from positive to negative.
There it is, positive to a negative, which means I need to find F prime. Well, the thing is, our problem was already in prime form, so it was 2,000 minus, and this is also a rate, so minus 400 square root of t, and that's the thing I set equal to 0. So when I set this thing equal to 0, then I get 2,000 is equal to 400 square root of t. And then from there, I'm going to divide both sides by 400, and this is going to be 50 is equal to square root of t. I believe that's the case, but I know I'm not allowed to use the calculator, but my math isn't what it used to be. Cheating. Oh, see, that's the reason why it's 5. I missed. Oh, there's 2 zeros. Yep, it's 5. See, 2,000 divided by 400. Yeah. It was 5. I could have simplified a fraction, but I'm lazy.
Wait,
So
shouldn't it be 50? Because there's three zeros on the 2,000.
you're right. So these 2 zeros cancel out, and then it's 20 divided by 4.
Oh, fine.
Yeah, I did the same thing, Rochelle. Don't feel bad. All right, and then therefore t is equal to
So that's going to be 25.
25. Yep. So t is equal to 25, and of course, if we finally do our correct number line at 25, we'll notice that when I plug in a number that's bigger than 25, this thing will be too big, and the negative will be too big, which means this is a negative, and that is a positive. It goes from positive to negative, so t equals 25 is the max value. All right, now for part C, we can actually do it. Write but do not evaluate an expression involving an integral that gives the volume of oil at the time found. So our integral is going to be from 0 to what? From 0 to 25 of our rate, right? 2,000 minus 400 square root of t, dt. Done. I apologize for that giant error. It's all Ben's fault. Not my words, Rochelle's words.
You said it.
Part number 6, Ben, we don't blame you. We love everyone here.
Wait, hold on. Go back a little. I got it.
All right, so let f be the function defined above. Which of the following statements about f are true? We're looking for true things. F has a limit. Well, that means it does exist. The double-sided limit exists. So I don't care what happens at 2. This is what happens at 2. It just says that at from the left and from the right, this approaches the same height. So what I'm doing pictorially for part 1 is saying pictorially, hey, do you have something that looks something like this or like this? Things that are bad, these are bad examples. Yeah, go away, skip that version. This is something that's bad because they don't approach the same height. This is bad, this is good. You don't need to write this down. I'm just showing you graphically what we're looking for. So on part 1, we just check from the left and from the right. So let's plug in something slightly positive. And of course, let's just simplify this all the way out. X squared minus 4 is x plus something, x minus something. What is it, Rochelle?
Oh, x plus 4 times x plus x minus 4.
What times what is 4?
Oh, 2.
Yeah, there you go. And then all of this divided by x minus 2, and then you can see that we do have a removable discontinuity, and it's at 2 it approaches the same height. So this one is true. This one is true because when I plug in 2, I get 4. When I plug in something slightly bigger than 2, I get slightly bigger than 4. When I plug in something slightly smaller than 2, I get something slightly smaller than 4. It approaches the same height.
Wait, wait.
Yes.
If you plug in 2, it equals 4.
Mm-hmm.
F has a limit at x equals 2, so that means like. What?
So when I plug in 2, my height is approximately 4. When I plug in approximately 2, my height is approximately 4 from both left and the right.
Well, isn't the height for x equals 2 is 1?
The height is 1. No, the height is 4.
No.
At 2, yes, but we're taking the limit. Limit doesn't care about the height. Limit is only caring about the left and the right. It doesn't care what's happening. It could be here.
The left and the right. The one that says x doesn't equal 2, that one's height is 4, right?
Yes.
But the one with x equals 2, the height is 1.
Again, so at x equals 2, let's say that this is 2. We do not care what happens at 2. At 2, it could be a height of negative 1,000, negative 1,000,000. I don't care at 2. I care what happens not at 2 because it's a limit.
Oh.
So I'm kind of ignoring that bottom part. But you are right. This is 4. This is 1. Usually this is a height of 4. This is a height of 1, which means they're eventually not going to match when I ask if it's continuous. So is it continuous? No. If it's not continuous, it's impossible for it to be differentiable. So which are true? 1 only. Again, this one has a height of 4 because when I plug in 2 to the reduced version, it turns into 4. All right, on to number 7. A particle moves along the x-axis with velocity this thing. If the particle is at position x equals 2, so this is the start. Everyone write this down. That's the start. At time equals 0, what is the position? So what is the end? End is equal to what, Rochelle?
Sorry, Daddy.
End is equal to start.
Plus change.
Start plus change. At 0, what was the start? What number?
Wait,
2, yep. Start was 2 plus, and then Rochelle, what is, how do I get position from velocity? I do what?
Antiderivative?
Antiderivative of 3t squared plus 6t, thank you. And this is going to be from 0 to, from 0 to
0 to 1.
0 to 1. Cool, we just need to calculate that thing and get our answer. So, here we go. It's going to be 2 plus antiderivative. So it's going to be, I'm going to go up a power. At 0, you're going to do an antiderivative, which is scary, I know. T to the power of 2, this is going to go up 1. 2 is now a 2 plus 1, 3. It's going to go up a power, and then I'm going to divide down by that power. So divide by this thing. This is t cubed. Divide by, there it is, t cubed divided by 3. And I already had this.
Wait, no, there's no 3 though because it gets canceled out.
Yes, so you skipped a step and you said, yeah, those 3's cancel out. Good job. And then at 0 again, you're going to do some calculus again. It's going to be plus. My wife is messaging me. Hopefully it's nothing important. Another house that I can buy. All right. So 6t. 6t. So this was a power of what right here at 0? If there's no power, you assume that power is This power, if there's no power, you assume it's 1, and it's going to go up power. So it should now be 2, and then I divide down, so it's divided by, there it is. Atziri took the derivative, and Atziri, can you reduce 6 halves for me as well? Yep, it's 3. That goes to 1. Cool, so our new derivative here from 0 to 1 is going to look like, bless you, 2 plus t cubed plus 3t squared from 0 to 1. All right, when I plug in 0, and again, this evaluation bar applies to this thing. When I plug in 0, nothing happens. So at 0, what's 1 to the power of 3? What's 1 times 1 times 1? 1 times 1 times 1, 1 cubed. What's 1 times 1? 1 times 1 is 1. 1 times 1 times 1 is?
1 times.
1. Yeah, there you go. So it's 2 plus, and then it's 1. And then what's, again, at 0, 1 squared? 1 times 1? And then times 3. 1 times 3, yep, plus 3. And then at 0 again, 1 plus 3. 1 plus 3. 4 plus 2. At 0 found 6. Man, Rochelle needs to do more work. At 0's doing all the heavy lifting. She had to do the antiderivative. She had to plug in all of those bounds.
Wow, okay.
God.
So that's the one that says, Atziri, do this, Atziri.
Good job, Atziri. You're hanging in there. All right, number 11. And if people are watching this 5 years in the future and don't know who Atziri is, she's my geometry student. Number 11. The graph of a function f is shown above. Which of the following could be a graph of f prime? All right, so this is a graph of f. So the slope on a graph of f is equal to what on a graph of f prime? Rochelle?
What?
The slope on the graph of f is equal to what on the graph of f prime?
Wait, hold on. I got it. F prime.
You're looking for height, slope, or concavity. The slope is what on the graph of f? So slope on f
Height.
is equal to height of f prime. That turns into height.
But wait, here's a faster way you can see it just to like cancel out stuff. A max and min. You can like just find that, you know? You know what I'm talking about?
Yeah, so like this right here would be a, that's a max, right?
No.
Yes, it is.
Oh,
'Cause you're talking about-
I'm talking about something.
Oh, you're talking about like slope down here?
Like, okay, look.
This-
So on graph of f, you see the top one?
Yeah.
That and the bottom one?
Yeah.
Those tell you where they're gonna be crossing the line.
Oh, okay. So yeah, that's a good way to do it too. And
it's
that,
faster to take out stuff already.
yeah, because this is a slope of 0, which means it has a height of 0. And not only is it a height of 0, it goes from a positive to a negative. It is literally a max. That's what you're doing at the advanced level.
So
If it's a max, it goes from a positive slope to a negative slope. So it goes from a positive height to a negative height.
So A, C, and E get canceled out already.
So it goes from a wait, no. Why do you cancel out A?
Because
This went from a positive.
because it's not at the point where the max is.
Oh, I see. Yeah, it happened at 0. So yeah, A didn't happen there. If it happened right here, it would have been okay.
Yeah,
I
like
see.
B.
Can't be C because it's not a max. That's a min. This was a min. It can't be D because there's no max happening over there, and it can't be E. So you just found the answer. It's B, just by that 1 point alone. Yeah, very nice, Rochelle. Thank you. She's doing the heavy lifting now. At 0, you need to do more calculus. Jeez. All right, the last question for the video, number 12, and then that last sheet you have to do by yourselves.
Taxman.
Oh, it is not actually. Taxman is when you go backwards, right? We're going forwards. So derivative of E house is
Just E-house.
E house. So rewrite it. E to the power of 2 divided by x. And then don't forget,
Dinner.
it doesn't actually,
Dinner.
just dinner, right? We're not going to starve. We're going to multiply by dinner, which is,
2.
ooh, you have to be careful.
Oh,
There.
wait. So that's 2x to the power of -1.
2x to the negative 1. I agree. Those are the same things.
Subtract 1. You subtract 1. Okay, so it's going to go down first. So it's going to be -2.
Yep. And then divide down.
negative x to the power of -2.
Yep, so I'm going to rewrite this. This is the same thing as e to the 2 over x. All of that times 1 over x squared. So x squared is on the bottom. Or I'm looking for a there's x squared. What's going on here? Why do I have a... No, we don't need any natural logs. You can cancel that guy out. If you did the antiderivative of this, then yes, but we're taking the derivative. What just happened here? Why is Mr. Sandell making so many mistakes? We divided down. We should get a negative.
You forgot the negative x squared.
Yeah, this should be negative. But I'm still not seeing that answer. I see something that has an x squared in the bottom, but it has a 2 up here. That 2 should have canceled out. So this one forgot dinner. This one,
Oh, it's something else.
yeah, it's between D and E. What are we doing wrong here?
What?
2x to the -1. If you take the derivative of this, oh.
What are we supposed to?
Oh my gosh, Rochelle, we don't know how to take the derivative. Let's come back. Let's try again.
What?
Try taking the derivative again.
Oh, so then I was right. It was just the fact that you were putting something else.
Okay, tell me what the derivative is then. If you're...
Shouldn't it be can I do it on the board?
No, just tell me.
Hold on. So you add 1.
Nope, you're taking the antiderivative.
So you subtract 1.
Nope, that's not the first step.
Wait, what?
Divide down, or you multiply down first.
You multiply down?
This gets multiplied down. What's 2 times -1?
-2.
Okay, you multiply down, and then
You add 1. I mean, subtract 1.
Subtract 1. There we go. Whew. All right. Now we know how to take the derivative. Now we're going to turn this into
It's very confusing.
a 2, and the answer is E. No, it's D. There it is.